is a MaaS governance and business model, how to orchestrate mobility and make it robust, secure, and financially viable in a decentralized approach. And Josep Sanjuas is going to be the next expert presenting. He's the CTO and co-founder of Iomob. He received a PhD in computer science from the UPC Barcelona Tech in 2012 and co-founded and led the UPC spin-off Talaya Networks, later acquired by Auvic in 2018. At Iomob, Josep channels his passion for decentralization and blockchain technology into building the Internet of Mobility, a global decentralized mobility network. Thank you for being here, Josep, and welcome. You can share your screen when you're ready and start presenting, please.
Hi, it's my pleasure to be here with you. I'm going to share my presentation. Hopefully you can now see it in full screen. So yes, I'm going to talk about decentralized mobility as a service, governance, and the economic incentives behind it. It's not a very long presentation, so please do use the questions time to ask away. What I'm going to do first is set a vision of what we mean by decentralized mobility as a service in the Moliere project, which also maps very well to what we are building at Iomob as the Internet of Mobility. So there's lots of things that decentralized mobility as a service could mean, and I'm going to set a vision of what we mean in this project. So it's basically anchored around two main principles. One is decentralized mobility as a service has to be globally interoperable as an infrastructure, so that, as Boyd said before, the same user interfaces you use in one city or in one country or in one continent have to also work in another continent. The only way this can be achieved is if this infrastructure is built with an interoperable approach, so that the APIs and infrastructure that is used by a user interface to connect to a mobility service in one city or in one area of the world also works in another area of the world with the same user interface. The other main principle, and this is where the decentralized concept is crystallized, is we want this infrastructure to be neutral and not under the control of one single organization. So what that means is that any element of the infrastructure can be operated by any stakeholder and not in exclusivity. So if you compare it to a traditional, what's usually called Web 2.0 model, the infrastructure is under the control of one single company, which has, of course, its own incentives and profit-seeking desire, and this introduces significant platform risks for all the involved stakeholders. So imagine a centralized mobility as a service platform that is global and is reaching a critical mass, and it's operating at a big scale. Then what happens is that the company behind this platform can take unilateral decisions to raise, say, transaction fees, to veto mobility services, or to favor mobility service in which the company has a financial stake. So this introduces all these platform risks for both for the mobility services that participate in this network, but also for the user interfaces or the apps that are connected to this platform, because they are subject to the whims of this centralized company that has a complete hold over how the platform operates. So that's why we value that the mobility as a service infrastructure has to be decentralized, has to be neutral, and not under the control of one single organization that can push its desires on the whole ecosystem. So what are some challenges in building a decentralized mobility as a service infrastructure? Well, we want to maintain global interoperability. right? As I said before, the same application to access mobility services has to work in any country, in any city, in any continent. And this is achieved via standard APIs. Even though the network has to be globally interoperable, it also needs to consider local particularities. In particular, these can be regulations, laws about what can and cannot be done in each area, whether it's about mobility services themselves or data processing. The other challenge is to build this network in a way that every stakeholder stays economically motivated to perform its job and to, I will add, join the network in the first place. So aligning the incentives for the broader good of the ecosystem is an issue. So who are these main stakeholders in decentralized mobility as a service? So of course we have mobility service providers. These are the players that basically offer mobility services in this decentralized mobility as a service infrastructure, which you can see in the end as a kind of mobility marketplace, right? So mobility services can be offered and they can be purchased by end users. So the end users connect to these mobility services through this mobility as a service infrastructure via what we call demand partners. And demand partners are basically any kind of company organization operating a user interface that facilitates access to these mobility service providers. So this can be, usually they are mobile apps, but they could also be, say, any kind of web interface where, for example, nowadays you can buy airline tickets and also purchase, say, for example, a car rental. So this would also be a demand partner in this framework. And then there's finally the MaaS platform, which connects all these players together to create what's the glue that holds the ecosystem together. So the way we can have a global infrastructure with shared mobility, with shared aligned incentives, such that the ecosystem is bound together, while still being able to adapt this network to the specificities of each area in the world, is to split the infrastructure into layers. So we have the mobility layer, which is where the mobility services are exchanged. They are offered and discovered and purchased by end users. The mobility service providers and the demand partners can use unified data format and API specifications to access any of the local deployments, so that this application that is built, say, for example, in Barcelona, also works in Singapore by being able to locate what is the local deployment of each city as decided in the governance layer. So basically the governance layer is a layer where decisions are taken, and one of the key decisions, as we will discuss later, apologies, is to decide what are the local deployments and how they are operated. So the mobility service providers and the demand partners are connected to the mobility layers through these data formats and API specifications that are common to any local deployment. But the local deployments can be tailored to each region. This is how you achieve global interoperability, but also you get the ability to tailor each local deployment to each area. And they are all bound together by the governance layer. So what is the mobility layer? As I said before, the mobility layer is where the exchange of mobility services takes place. So the main features or functionality that the mobility layer offers is to enable the discovery of mobility services by end users, the combination of all these mobility services in integrated route plans to travel from A to B, and then the booking and payment of all these mobility services. As I said before, this needs the mobility layer needs to be split in regional deployments to account for local regulations or usage patterns. So as an example, we were in discussions with a big company in the UAE, and one of the requirements they set forth is the infrastructure needs to be hosted in the UAE. And many countries have their regulations. Of course, there's GDPR and all the rest that place boundaries on where the data can reside and how it can be transferred between regulatory boundaries and so on. And sometimes it's not even about regulation; it's just desires of the companies in an ecosystem for the data to stay local, or to enable certain kinds of mobility services that are particular to this area. So that's why the mobility layer needs to be tailored to these local areas, these local deployments. So at the same time, the mobility layer needs to operate with a degree of closedness, in the sense that the data about mobility patterns needs to stay private. It cannot be exposed publicly, as opposed to the governance layer, which needs to be very much public. In the governance layer, what we do is we make decisions, basically, and these decisions are made by token ownership votes, token ownership based votes. So there's players with an incentive or with an interest in helping the mobility as a service infrastructure succeed. So they own a stake of the infrastructure by owning tokens that represent this ownership. And these tokens represent not only the ownership, but also the decision power over any decisions that need to be made for the good of the infrastructure as a whole. Something we force in our design is all these governance decisions to be made by participants who have skin in the game. So participation in governance mechanisms requires locking tokens. And in the end, what we achieve is that good decisions are financially rewarded because token values go up. And the converse, if bad decisions are taken, then the value of the tokens goes down. And this is how we achieve an alignment of incentives, so that whoever participates in the governance of the infrastructure as a whole is also financially incentivized to do so in the right way. So the main decisions that are to be taken by the governance layer is to appoint the compute nodes to form local deployments, the mobility layer I said before that is split in all these local deployments. So the governance layer decides what are these local boundaries and what are the nodes that run in this local, basically the mobility marketplaces in all these local deployments. And then other maintenance activities such as upgrading the infrastructure and creating API specifications and updating them and so on. So let's talk about economic incentives. We said before that there are a few stakeholders in this infrastructure. One is mobility service providers. Mobility service providers are naturally incentivized to offer their mobility services for purchase at the right price tag. So they have, in terms of business model, no particularities, except for the fact that they need to make an investment in connecting to this decentralized infrastructure to offer their mobility services in there. So when you think about other stakeholders like demand partners, it's the same story. Like many operators of applications, or for example, in the rail industry, there's this big push to become door-to-door and stop being the companies that simply move citizens from train station to train station, but they move them from door to door. They are naturally incentivized to. I'm hearing a lot of background noise. I don't know if it would be possible to mute some participant that has the mic open. Anyways, where was I? So demand partners are incentivized also to offer integrated mobility services in their offerings, but it also is an investment for them to connect to this decentralized network, to make the investment to connect. So the theme of what I'm saying in this last few sentences is when the decentralized mobility as a service network is already big, all these all these motivations to join work very well. But there's a difficulty, which is kickstarting this network effect. So at the beginning, who is going to connect to this infrastructure when there are very few demand partners, and what demand partner is going to connect to this network and make the investment to integrate it in their app if there are very few mobility services. And one of the answers we've found is to incentivize growth early on. So because we have the governance layer, which is governed by tokens, we have this mechanism, this unit of account, the token that has some value. So we don't know exactly what that value is, but there is some value, right? Because these tokens represent the decision power in this network. So what we can do is we can offer incentives in terms of tokens to the parties that are involved in delivering real mobility services. So these parties are really any stakeholder involved in this. So it can be the demand partner itself, it can be the end user, it can be the mobility service. So an example of such an incentive would be we award a number of tokens for every kilometer that the user has traveled with an enabled service that offered by the Mobility as a Service platform. So in the end, we compensate the cost of integrating in the infrastructure. And this is especially important to kickstart the network effect. And a side benefit of this approach is it distributes the token ownership with all the parties involved in the network. So when we have a governance layer that is token governed, we have a problem, which is, well, how do we get these tokens in the hands of participants who are interested and have a stake in the well-being of the network? So as a side benefit of offering incentives based on delivery of real mobility services is that we are also distributing tokens to those stakeholders with an interest in the network. A counterpoint to that is that when we offer incentives, economic incentives, then in a decentralized network there will be fraud. This always happens pretty much because these networks are very open. Anyone can participate, meaning anyone can come up with ways to cheat the system and try to extract these economic incentives via fraud. So an example of this would be somebody setting up an existing mobility service in some area and then pretending there is an application running in this area and reporting fake usage of this application, right? So this is why we've come up with an approach we call proof of mobility service, which is these mechanisms we have designed to prevent fraud. The aim of this is not really to prove definitively mathematically that a mobility service was delivered, because this is very hard, but to make it impractical to cheat. So to have sufficient mechanisms to prevent this kind of cheating. One of the ways we are testing this is introducing verification of services via neutral third-party companies or organizations that can verify whether, or help us verify whether a mobility service really took place. In the Moliere project, we're working on verifying that mobility services reported by a car sharing fleet really happened by deploying sensors in the vehicles that are created, operated, and installed by a third-party service that collects information on the usage of all these mobility services. So with this, I will finish, and please ask any questions that you might have.
Hello.
Hello, I hear you.
Excuse me. Oh, thank you. So excuse me, sir. It's been a great interpretation of the technical issues here. So I have recently encountered one question about some of the enterprises felt a little bit hesitant to open up their APIs. Will there be any ethnic related concerns for this kind of behavior, or maybe your project can help solve that problem? And that will be all. Thank you.
Yeah, thank you for the question. So I think, I mean, there's many ways in which opening up APIs can be incentivized. One of them is even regulation. I think in Europe there are some initiatives to try to encourage all the mobility service providers to open up APIs so that the fragmentation problem is ameliorated. But more generally, I think what works best is the carrot better than the stick. So what we're trying to do is setting up, first of all, a standard so that all these companies, they have to implement one standard to connect to a mobility service platform, mobility as a service platform, instead of each platform having its own API spec. So to simplify the problem, then we are adding all these token incentives for these companies to want to join. So hopefully this offsets the cost of this integration. And another way in which this can be tackled is these financial incentives might not have to go to the companies themselves that perform this integration or that open up their APIs for this infrastructure, but instead they can go to integrators. So integrators can invest in connecting these companies to the infrastructure in exchange for this token reward. So it's a win for all parties. The integrator gets paid for its job. The mobility as a service platform gets more mobility services connected, and the mobility service provider gets demand from the network without having to go through the effort of integrating the network. However, it's an easy. I don't want to oversimplify. I think it's not easy to make it happen.
Thank you for enlightening. Thank you.
You're very welcome. Thanks for the question.
Well, thank you, Josep, for your presentation. I want to encourage the audience to, if they have any more questions for Josep. Meanwhile, I'm going to share the second Mentimeter. Which is, were you aware that one of the ways to improve the governance of MaaS is by decentralizing mobility management? You can answer by entering Mentimeter or by the link I'm going to post in the chat. Josep, as anybody is asking, I'm going to ask you a question. How much effort is to build a centralized system as opposed to a centralized one? Is the added technical complexity warranted?
So I think it's much harder to build a decentralized system than a centralized one, because when you're building a decentralized system, you have to build everything that you have to build in a centralized way. In a centralized system, but also you have to worry about this property that the system cannot be in the hands of one single entity or company. So I would think it's an order of magnitude harder to achieve it. In terms of does it make sense to pay this cost? Is it something that we should be doing? I think we should, because mobility is, of course, extremely important. It's almost a human right. And the fragmentation in mobility is a huge problem, as Boyd explained in the first presentation. So if we want mobility to be, quote unquote, better, to be less fragmented, to be more easily accessible, then we don't want a private company to solve the problem of mobility fragmentation, because this one company will become too powerful, right? It will be a platform that will have just too much power in terms of dictating what mobility services can appear or be connected or be accessible, or playing favorites with, say, imagine a private company, a private mobility as a service was the one who achieved this big success in creating a mobility as a service platform. Then they would favor their own services over services that are maybe better for citizens, right? They would have just too much power. So I think it is very desirable for this infrastructure to be a success in a decentralized architecture as opposed to a centralized one. And this is why I think it makes sense to invest in this vision.
Thank you, Josep.
Very welcome.
And another last question for you. Okay.
Sure.
Are users supposed to pay with cryptocurrencies? Isn't that a big barrier to adoption? And more generally, how practical do you think your approach is? And can it work outside the lab?
Right. I think it's a good question, because we're talking about decentralized infrastructures, tokens, the role of blockchains in this architecture. I think it's a very natural question, and the answer is every user interface connected to this infrastructure can collect payments in any way, and that of course includes credit card payments or any payment methods that end users are more used to. And it would be a big mistake to create a mobility as a service infrastructure that requires payment in tokens, because this is, of course, yes, it is a way too big as a barrier for the adoption of this infrastructure. So the reason why we have split the role of demand partners and stated this role very generally, demand partners is a very generic term, is that we want any kind of user interface that wants to offer mobility services to any kind of users. It can be apps that face consumers, but it could also be apps that belong to a company and they are just used by employees to move around. And the way these user interfaces pay for mobility services is very easy. It's very different, right? So a consumer-facing app probably collects from credit cards. A corporate mobility solution probably just collects from the balances of the company, not via credit card payments. So we want to very much decouple how users are paying and how the money is collected from the mobility marketplace itself. So the role of the demand partner is to receive or capture the payments for the mobility services in any way. And then, yes, it settles these payments with the mobility services over this decentralized network using tokens, cryptocurrencies, or whatever the right mechanism is for these players. And same goes for the mobility service providers. Like they can announce the service, the cost of the service is in euros, USD, whatever the currency. And then exactly how these are settled inside the mobility as a service network is decoupled from that.
Perfect, Josep. Thank you. And now we can see that 9 of you have answered the question. If you were aware that MaaS can improve the governance by decentralizing mobility management, 3 of you answered yes, absolutely. 2, yes, I've really heard about it. And 4 of you were not aware at all of that. Okay, so thank you for participating. Thank you, Josep, for your intervention.
Lucas, sorry to interrupt, but I think we have another question from Patrick back in the chat.
Yes, sorry.
Oh, I see it. Yes, we have a question which is, in regards to centralized versus decentralized, will we have one validator per city or per local area? And if so, is it really decentralized? So I think the answer is it's way more decentralized, of course, if there is more than one validator per area, because when you have one validator per city, then basically the infrastructure is run by this one validator or compute node. And then it's very traumatic to migrate away from that node to another computing node, because there is data migration requirements, there is downtime probably associated to these operations and so on. So we are very much working in the decentralization of the mobility layer, so that there is basically a private blockchain running in each local deployment, so that compute nodes can be accepted or removed more dynamically, as opposed to a situation where the local infrastructure is run by a single compute node, which introduces all these difficulties. It's hard to replace it. And then if it's hard to replace a player that is running a key part of infrastructure, then this diminishes the degree of decentralization of this infrastructure.